Welcome back, scientists. Let's jump right into this explainer. We're going to review everything we figured out from lessons 1 all the way through 9, just to make sure you are totally locked in and ready for your assessment. We've been on a pretty incredible journey over the last few weeks, investigating some massive, earth-shattering mysteries. Literally. And today we're putting all those puzzle pieces together.
So, to kick things off, let's anchor ourselves right back to the driving question that sparked this whole investigation. What actually causes Earth's surface to change? That's the big picture idea we've been tackling, right? And we're going to trace our evidence step by step to answer it.
I want you to think back to lesson 1 and that mind-blowing phenomenon we looked at. Mount Everest isn't just sitting there frozen in time. It is actively moving, and it's actually growing in elevation. We had to figure out why. Like, how in the world can a landmass that gigantic just change its size and location? It's wild to think about.
Okay, here is our study roadmap for today. We'll start with the Mount Everest mystery, then untangle earthquakes, correlation, or causation. After that, we'll do some digging beneath the surface, explore how Earth's plates interact, and finally, we'll build the causal chain of events.
All right, Section 1, the Mount Everest mystery, investigating the clues.
If you remember, we started with surface-level clues, specifically footage from that massive 2015 event. We saw the sheer destruction, we listened to the accounts of the hikers on the mountain, and we had to ask ourselves, could sudden violent shaking be the culprit? I mean, could an earthquake actually push a mountain higher into the sky?
That brings us to Section 2, earthquakes, correlation or causation, untangling the variables.
Now, listen up, because this is a major point for your assessment. You absolutely have to separate these two concepts. Just because earthquakes happen near growing mountains, well, that doesn't mean they actually cause the growth. Correlation simply means two events are happening at the exact same time or place. But causation, that means one event is directly making the other event happen. That is a massively important difference in science, guys. To untangle all this, we built a logic map of potential causes and effects together in class. We had to systematically test our observations. We needed to see if earthquakes, wind, or maybe tectonic plates were the real cause. Or if, just maybe, earthquakes were simply another effect of a much larger hidden force going on behind the scenes. Moving right along to Section 3, digging beneath the surface, examining the materials. Since surface events like weather or earthquakes weren't giving us the whole story, we knew we had to literally look deeper. We investigated what the Earth is actually made of, looking at data from deep mines and drilling operations, just to figure out what was really down there beneath our feet. That brought us to sediment. Make absolutely sure you know this vocabulary word for the test. Sediment is just the loose Earth materials, sand, dirt, rocks, sitting right on the surface. But beneath that sediment, there is a massive, thick layer of solid bedrock. Getting that distinction down was our crucial key to realizing that entire slabs of solid Earth might actually be in motion. Which leads us to Section 4, how Earth's plates interact, the suspects in action. So the real mystery was figuring out what happens to all that solid bedrock. To do that, we zoomed way out to a global scale. We looked at places like the Mid-Atlantic Ridge to gather evidence about how plates separate and move across the entire world. And seeing that data was a real light bulb moment. It showed us that Mount Everest wasn't just some random, isolated incident. No way. It's part of a massive, dynamic, global system of interacting tectonic plates. Think back to when we got our hands wet and built those physical foam and water models. We saw plates moving apart, plates sliding past each other, and plates crashing together. When those foam edges pushed into each other, the material had literally nowhere to go but up. That right there represents exactly how a mountain grows. And when those rough edges get caught, build up tension, and then suddenly snap past each other, bam, that violent release of energy, that's your earthquake. All right, let's bring it all home. Section 5, the causal chain of events, solving the mystery. We've got all our clues, so let's solve this case just like we did in Lesson 9. This right here is the exact causal chain you need to memorize for your test. Step 1, liquidy rock, or magma, moves deep underground. Step 2,
This flowing magma acts like a conveyor belt, forcing the giant, solid tectonic plates above it to move. And step 3, when those plates crash together, it causes our mountain's surface to change elevation. So the earthquake didn't cause the mountain to grow. Instead, the moving magma caused the plates to move, which simultaneously built the mountain and caused the earthquake. We finally untangled it. We separated correlation from causation.
I'm going to leave you with one final, kind of mind-bending thought to ponder as we head towards Lesson 14. This really proves just how powerfully these hidden forces shape our world. If magma and tectonic plates crashing together can push huge land masses up into the sky over millions of years, how could that explain finding a marine fossil, literally an ancient ocean creature, at the very top of Mount Everest? Keep that in the back of your mind as you head into your assessment. Good luck reviewing your notes, scientists. You've got this, and you are going to do absolutely amazing.